Let's talk about standard in. So the two that we've talked about so far, standard out and standard error, those are output streams, right? There's something flowing out of an output. You can also feed things into standard in. So cat has a fun ability that not only can it read files, it can have files inputted to it. So if I put a angle bracket in the other direction, I can actually read out of a file and throw that into cat. So if I put like, what files do I have in here? New file. So this is actually going to read out of new file and throw that as an input into cat, and cat is basically just going to output whatever it gets. So in this particular case, this isn't very interesting because if I just do this, it's the same thing, right? Because that's what it does, is it reads a file. But that actually does end up working. But let's say here, what's in my ls.txt? Oh yeah, so I have this in here where it's just two outputs of an ls, right? Let's say I wanted to read from this file and find something in it. So you could actually do something kind of interesting here where I can say, let's look for ls error. So I'm going to say grep, which we'll talk about here towards the end of the class. Grep is just like a thing to like look for other things. So I'm going to say grep for ls error.txt, and then I'm going to input into that ls.txt. So what this did is it read from the file ls.txt and then it fed that into standard in, which then connected into this grep program, and grep looked for this line of text right here, ls error.txt. So this is really great, like if you have a program that like you're going to be giving it like a consistent amount of input and you get sick of typing it over and over again, you can use this to just like write it to a file, and then you can feed that into a program. I don't end up using it a lot, I'll be honest with you, but it's just good to know that that exists. More importantly, it's good to know what you can pipe from one program to another, which we'll get into here in just a second. Let's put this all together now. I'm going to go into my streams folder, and I'm going to grep for ls error.txt. Oops. And I'm going to input into that ls.txt, and then I'm going to pipe the output into grep.txt, and I'm going to ignore the errors. Okay, so what the hell just happened, right? Like, it's a little dense, but we know everything that went into this, right? So we have ls.txt, this is being read and put into standard in. That's being fed into grep, which is looking for ls error.txt. It's then outputting the standard out into grep.txt, and it's ignoring all of the errors. So if I cat grep.txt, what do you expect to find in there? The two found ls errors. Make sense? Now again, something interesting. Notice that this ls error is not colorized. Whereas if I do this, it is colorized. That's because grep is smart enough to say, like, you're running this through a pipe, and I'm not going to put any colors onto this because that makes it harder for machines to parse, and that's just for human benefit. So it omits all the colors to make it more easy for the next thing to read. And order is not important here for this particular command that we wrote here. So you could put the standard in and standard out and standard error in any order that you want to.
Questions about the one character before the redirection operator?
Oh, the one character, this one. I thought you were talking about the one character, right? Like that one?
Yeah.
Yes. So if you put a 1 there, you're redirecting standard out, and if you put a 2 there, you're redirecting standard error. Why is it a 1? Because it's the first one. I don't know if there's a really good reason to it. It's just the way that they wrote bash. And then again, if you leave it out, it redirects both standard error and standard out.